Hey everyone, welcome back. Thanks for checking in today. Our next look at area is going to be area of regular polygons. So a regular polygon is just any polygon who has all their sides or all their angles congruent. Okay, so a couple definitions here, a couple new vocab words. The center of a regular polygon is equidistant from the vertices. So you see in the picture on there, C is the center, and it's the same length from all the vertices D, E, F, G, and H. The apothem is a distance from center to a side. So in our picture down there, CB is an apothem. A central angle of a regular polygon has its vertex as the center and its sides pass through consecutive vertices. So this would be one central angle. And in fact, this one would have 5 central angles because it's a pentagon, 5 sides. To find the measure of a central angle, you would do 360 divided by the amount of sides there are. Regular pentagon DEFGH has a center C, an apothem BC, and central angle DCE, or many others as well. To find the area of a regular n-gon, so n is just any number, with side length of S and apothem A, we divide into n congruent isosceles triangles. We learned earlier in this chapter the area of a triangle would be base times height over 2. Right? So let's take a look at this triangle right here that I've highlighted in blue. Okay, the base would be FE, which is the length of one side, so we'll call that S. The height would be the apothem, so we'll call that A. So the area of that one triangle right there would be A times S over 2, the height times the base over 2. And then since there's 5 of these, we just multiply it by 5. But let's make it so that we can use this for any regular polygon. Really, all we're going to do is we're going to multiply S by however many sides there are. In this case, it would be 5, but in general, all we're doing is we're getting the perimeter. So we're going to take that S and we're going to change that into a P for perimeter. So the area of any regular polygon will be given by the formula AP over 2. Apothem times perimeter over 2. Here are some polygons by side that you should know. Pay real special attention to pentagons, hexagons, and octagons. We'll work with those a lot in this section, but really we should know everything up to 12. Anything above 12 we just call an n-gon. So for example, if it had 16 sides, we would call it a 16-gon. So here it is, our formula again. 1/2 times apothem perimeter. Again, I like to write it like this, but it's the same thing. 1/2 times AP or AP over 2. And that's it. Let's take a look at a couple problems. So example 1 says, find the area of a regular pentagon with side length of 4. So let's start by drawing a pentagon. We know a pentagon has 5 sides. And we also know that this pentagon has side lengths of 4. All right, so first thing we're going to do is we're going to find the center. And we're going to use the center to draw in a apothem and a radius. I know you're probably thinking it's not a circle, it's a radius, but yes, these all do have radii as well. And that's just the distance from the center to a vertex. And we know the apothem is perpendicular, so what we did is we just created a right triangle, which I'm going to draw a little bit bigger over here. I know this is 90. I also know the length of the bottom side here would be half the length of a side of the pentagon, so this would be 2. I do not know the length of the apothem, nor do I know the length of the radius, but that is not important. We're not going to need that for this problem. So to find the measure of a central angle, now first of all, we don't have a central angle drawn, so let's finish this triangle off. This is a central angle. Okay, we'll call that whole thing theta. Theta is going to be 360 divided by how many sides there are. In this case, there are 5. So theta is 72 degrees. But in our red triangle there, that's just half the big purple triangle. So if we cut 72 in half, this angle up here would be 36 degrees. We then could find this angle over here if you wanted to, but that is not important as well. We have one angle, one of the acute angles, that's all we need. Now we have enough information to find A, which we need to do. Using trigonometry that we know, if we look at 36, 2 is across from 36, or opposite it. A is next to 36, or adjacent to it, so we're going to use tangent of 36 equals opposite over adjacent. Okay, if you multiply both sides by A, that would give us A tangent 36 equals 2. And divide both sides by tangent 36. That gives us A equals 2 over tangent 36. And if we type that into a calculator, we get the apothem is approximately, now I would suggest writing this down to a couple decimal places here. I'm going to go to 4, 2.7527. Remember, our job is to find the apothem, which we just found, and the perimeter, which we don't have yet, but we can find that really easily. One side is 4, there's 5 sides, the perimeter is 20. Okay, now we have everything we need to answer this question. The area equals the apothem times the perimeter over 2. And we're going to round this to the nearest tenth. Our area is approximately 27.5 square inches. Second one, find the area of a regular hexagon, 6 sides, with apothem 12 centimeters to the nearest tenth. All right, let's draw a hexagon. Find the center. Draw in an apothem, which we know is 12 centimeters. And draw in a radius as well. So I'm going to draw that triangle bigger again. We know this is 12. We don't know this side. I'm going to call it X, and we don't know the radius, so I'll call it R, but again, we don't need that for anything. All right, let's start here by drawing in the rest of this triangle, and then we're going to find this central angle here. So it'll be 360, so theta equals 360 over 6, which is 60, and if we cut that in half, we get 30. So this angle up here is 30. So now we can set up the equation. Tangent of 30 equals x over 12. Multiplying both sides by 12, I get 12 tangent of 30 is equal to x. So x is approximately 6.9282. All right, now x doesn't represent anything in this problem. Remember, we need to get the apothem and the perimeter. We have the apothem. It's 12. We don't have the perimeter, but we now know this is 6.9282. If we multiply that by 2, that'll give us the length of one side. So our side length is 13.8564. And then we can multiply that number by how many sides we have, which is 6, and that will give us our perimeter. Our perimeter is 83.1384. And now we have everything that we need to find our area. Apothem times perimeter over 2. And our area is 498.8 square centimeters. On example 3, we have an octagon, 8 sides. So 1, 2, 3, 4, 5, 6, 7, and 8. There's our octagon. And we know that one side length is 2. So all these are 2. You see I've already drawn in my apothem there. And I'm going to finish by drawing in this right triangle. And actually I'm going to complete the triangle here as well. And I'm going to draw that little triangle a little bit bigger out here. So I know that the whole side is 2, which means this piece here is 1. So this is 1. I don't know the apothem and I don't know the radius. So first thing we need to do is find this angle. So theta equals 360 over 8, which is 45. And if we cut that in half, for the little triangle there, we get 22.5. So this angle up here is 22.5 degrees. So now I can do tangent of 22.5 equals opposite over adjacent. If I multiply both sides by a, I get a tangent 22.5 equals 1, and dividing by tangent 22.5, I get a equals 1 over tangent 22.5. So a is approximately 2.4142. So we have our apothem. We pretty much have our perimeter, because remember the side length was 2 and there's 8 sides. So our perimeter is 16. So we have everything we need. Area equals apothem times perimeter over 2. And our area is approximately 19.3 square feet. All right, at this point, there are 2 problems left that you can try on your own. Go ahead and pause the video. When you finish them both, come back and check your answers on the last 2. Here's the answer to number 4. And the answer to the last practice problem. That'll do it for section 9.4. We have one section remaining in this chapter, which we will combine a lot of the things that we've learned to try to find the area of composite figures. We'll see you next time.